Peter Lindemann, who I've known for a long time. He used to be a vice president with Borderlands Sciences Research Foundation, and it was in that capacity that I first met him. Borderlands was the publisher of my first book, Design Ecology, and they were a wonderful organization back when he was working with them, and I really appreciated the opportunity to get to know him and the other people who were working there. Peter has studied with Bruce De Palma, Eric Dollard, John Bedini, Trevor Constable, all great, great people in this field. He's the author of The Free Energy Secrets of Cold Electricity, which is one of the most popular books at Tesla Tech, and for very good reason. And he's also currently the president of ClearTech Incorporated, which is his own company up in Liberty Lake, Washington. So let's welcome Peter Lindemann.
Testing. Thank you all for coming. I think it's appropriate, since I'm the last speaker, that we once again thank Steve Elswick and Terry and Michael and John for the tremendous and astonishing effort that it takes to put together one of these conferences. And the title of my talk today is Tesla's Radiant Energy, and it's in honor of Tesla's 150th birthday, which was about 20 days ago. We owe him a great debt of gratitude for all of the technologies that he gave us, and probably the one that is the most misunderstood are his patents on radiant energy. On November 5th, 1901, Tesla was granted 2 patents. It's very rare that patents are issued in consecutive numbers, as you can see here, but both of them issued simultaneously, and one of them is apparatus for the utilization of radiant energy, and the other is method of utilizing radiant energy. And this is a pattern that Tesla has used for a wide number of years already, where he will essentially get one patent for what the whole process is, the method of. You will see this in a number of other slides that I show. And then he gets a second patent for a machine that applies the method. So many of these patents are relatively similar in their wording, but they have different purposes. And so we're going to look into this today. Of all of Tesla's work, these 2 patents are probably the most mysterious and misunderstood. Can you hear me? Because it's already feeding back. It's just like, John, where are you? Can we get an AV guy here? What happened to him? I have no idea which knob to turn here, so anyway. Okay. You know, it's... well, it's hard because I'm going to move my head around, so it's... anyway, just... Yeah, but we can't have it too high on the feedback side. So can everybody hear that? Yeah. Okay, great. Okay, well then we'll just go with this. Of all of Tesla's work, these 2 patents are among the most mysterious and misunderstood. So the questions arise: what is radiant energy? How is it produced? How is it harnessed for power? And these are the questions that I hope to help bring an understanding to you in the next hour. The best way to start is to actually read the patents. What a novel idea. And to do this, I'm going to start with 3 basic assumptions. I'm going to assume that Tesla knew what he was doing, that he had sufficient command of the English language to accurately describe what he was doing, and that he wanted to communicate to us what he knew. Now, these aren't always assumed, but I wanted to make these assumptions out front because I take these things for granted. So, what did Tesla say? This is the first quote from this patent, and I'll just read it. It says, "It is well known that certain radiations, such as those of ultraviolet light, cathodic, Röntgen rays, or the like, possess the property of charging and discharging conductors of electricity, the discharge being particularly noticeable when the conductor upon which the rays impinge is negatively electrified. These radiations are generally considered to be ether vibrations of extremely small wavelengths, and in explanation of the phenomena noted, it has been assumed by some authorities that they ionize or render conducting the atmosphere through which they are propagated." Then he goes on, "My own experiments and observations, however, lead me to conclusions more in accord with the theory heretofore advanced by me, that sources of such radiant energy throw off with great velocity minute particles of matter, which are strongly electrified, and therefore capable of charging an electrical conductor, or even if not so, may at any rate discharge an electrified conductor either by carrying off bodily its charge or otherwise." So here we have in Tesla's own words, he says, "I don't believe the standard theory, and here is what I think is happening." He goes on, "In applying my discovery, I provide a condenser, preferably of considerable electrostatic capacity, and connect one of its terminals to an insulated metal plate or other conducting body exposed to the rays or streams of radiant matter. It is very important, particularly in view of the fact that electrical energy is generally supplied at a very slow rate to the condenser, to construct the same with the greatest of care." And finally this. "This phenomena, I believe, is best explained as follows. The sun, as well as other sources of radiant energy, throws off minute particles of matter, positively electrified, which impinging upon the plate P communicate continuously an electrical charge to the same. The opposite terminal of the condenser being connected to the ground, which may be considered as a vast reservoir of negative electricity. A feeble current flows continuously into the condenser, and inasmuch as these supposed particles are of an inconceivably small radius or curvature, and consequently charged to a relatively very high potential, this charging of the condenser may continue, as I have actually observed, almost indefinitely, even to the point of rupturing the dielectric. Inconceivably small particles in sunlight, streams of radiant matter creating electric charge, capacitors failing from overcharging from feeble currents." This image from the second patent actually has dozens and dozens and dozens of inventions within it. He shows basically that radiant matter from whatever source, a natural source like sunlight, can impinge upon plate P, or from an artificial source like a light bulb run from a one-wire power supply, can impinge upon this and charge the condenser. The condenser can be discharged either with a device that just senses the voltage in the capacitor and automatically discharges when the voltage gets to a certain point, which would be an automatic circuit controller, or it can be a timer that discharges it. Either way, when he discharges it, he can put an impulse, a capacitor impulse, through an inductor to draw down a and an iron bar which has a ratchet on it that turns a wheel. This is a capacitor-driven stepper motor. Or we can chop up the DC coming out of this and run a transformer and step the voltage up and run light bulbs. So he's got automatic controllers, mechanical controllers, stepper motors, capacitor discharge motors, transformers, lights. All of this seems like, why don't I have one of these already? Seems simple enough. To demystify these things and to decode these mysteries, I took my initial inspiration from Jerry Vassilatos' book, The Secrets of Cold War Technology. If you haven't read this book, you really need to. It's an astonishing book, and it really opens up the whole understanding of Tesla's technology and his model of electricity. Mostly for today's lecture, though, I have relied directly on Tesla's writings. This is an excellent book, and this is the book I've pulled a lot of quotes from. I also lean pretty heavily on his specific lecture that was delivered in 1893 titled On Light and Other High-Frequency Phenomena. But I also have used and found quite useful the impossible-to-find volume of Tesla's Vocabulary for Dummies. Now, so this really helped me because I'm pretty slow, and I've been working on this for about 20 years, and it's only recently that I figured this stuff out. So this has been a very, very helpful book, and you probably won't be able to find any copies, but I'm glad I've got one. Anyway, so with all of these tools at our disposal, let's retrace the steps and see if we can decode what Tesla meant by radiant energy. In his article of June 1900, The Problems of Increasing Human Energy, Tesla said, about 33 years ago, Maxwell, following up on the suggestive experiment made by Faraday in 1845, evolved an ideally simple theory which intimately connected light, radiant heat, and electrical phenomena, interpreting them as being all due to vibrations of a hypothetical fluid of inconceivable tenuity called the ether. No experimental verification was arrived at until Hertz, at the suggestion of Helmholtz, undertook a series of experiments to this effect. Hertz proceeded with extraordinary ingenuity and insight, but devoted little energy to the perfection of his old-fashioned apparatus. The consequence was that he failed to observe the important function which the air played in his experiments, and which I subsequently discovered. Repeating his experiments and reaching different conclusions, I ventured to point out this oversight. The strength of the proofs brought forward by Hertz in support of Maxwell's theory resided in the correct estimate of the rates of vibration of the circuits he used. But I ascertained that he could not have obtained the rates that he thought he was getting. The vibrations with identical apparatus he employed are, as a rule, much slower, this being due to the presence of air, which produces a damping effect upon a rapidly vibrating electrical circuit with high pressure, as a fluid does upon a vibrating tuning fork. I have, however, discovered since that time other causes of error, and I have long ago ceased to look upon his results as an experimental verification of the poetical concepts of Maxwell. That's different. This is the statement of a man who is losing the first industrial standards war. His 60-cycle AC polyphase electricity system was adopted by the financial and industrial powers in New York in 1888. But when he came up with something much better, that technology was frozen out of the market and he was slowly marginalized. But that did not stop him from protesting periodically when he had the chance. So, just so we understand, Tesla's saying James Clerk Maxwell is a poet. His work is to be ranked with H.G. Wells and considered art or science fiction. Heinrich Hertz did not verify Maxwell's prediction and did not discover electromagnetic waves. So, that's not controversial enough. Let's go back to the beginning and find out what has happened to make Tesla say things like this. In his lecture on light and other high-frequency phenomena in February of 1893, 7 years previous, Tesla said, "The day when we shall know exactly what electricity is will chronicle an event probably greater, more important than any other recorded in the history of the human race." This is the task that Tesla set for himself. He decided to figure out what electricity is. Reading also from this lecture, we cannot help wondering when we observe two magnets attracting and repelling each other with a force of hundreds of pounds with apparently nothing between them. We have in our commercial dynamos magnets capable of sustaining in midair tons of weight. But what are even these forces acting between magnets when compared with the tremendous attractions and repulsions produced by electrostatic force, to which there is apparently no limit as to intensity? Now, I don't know about you, but we were all taught that electrostatics were a novel and feeble nuisance, and that magnetism was the powerful force. Here, Tesla is saying the opposite. And he goes on, he says, "The first class of effects I intend to show you are effects produced by electrostatic force. It is the force which governs the motion of the atoms, which causes them to collide and develop the life-sustaining energy of heat and light, and which causes them to aggregate into an infinite variety of ways according to nature's fanciful designs, and to form all these wondrous structures we perceive around us. It is, in fact, if our present views be true, the most important force for us to consider in nature." And again, electrostatic attractions and repulsions between bodies of measurable dimension are, of all the manifestations of this force, the first so-called electrical phenomena noted. So here he's talking, remember this quote when we get to understanding what he thinks electricity is. This is electrical energy without magnetism. And again, as the term electrostatic might imply a steady electric condition, it should be remarked that in these experiments the force is not constant, but varies at a rate which may be considered moderate, about 1,000,000 times a second or thereabouts. This enables me to produce many effects which are not producible with an unvarying force. So here in 1893, Tesla's saying that 1 megahertz is a moderately marginal, middle-of-the-road frequency. Nobody even was close to producing these frequencies in these days. And here from this lecture again, this diagram, Tesla's method of conversion. 113 years ago, Tesla has discovered how to convert normal electricity into something else, using simple inductors, capacitors, spark gaps, spark disruptors, operating at high frequency. So, I want to point out a number of these designs. This is the one that we focused on in my book, Free Energy Secrets of Cold Electricity. It's basically, he starts with a dynamo that can put out either a DC on these brush commutator or AC on these slip rings. And so on the DC side, he comes over here and he's decided, well, the voltage isn't high enough, so he puts it through this rotary dynamo, rotary transformer basically, that runs as a DC motor at 1 voltage and produces an even higher voltage DC coming out the other set of brushes. Then he charges this capacitor. Then he discharges it across this magnetically quenched spark gap to run these little things. Every time you see this little symbol here, this little circle here, this is a light bulb in his system. Okay? The other thing he shows here, right next to it, is a DC motor again, but this time it's driving a super high frequency AC output on slip rings that drives a transformer. He's stepping up the voltage here and charging and discharging a capacitor, which then he puts across a double spark gap here so that this thing can ring, and then with outputs. And you'll see that this diagram right here, this section of it is the same as here. So he can run this circuit either from a DC source or directly from an AC source if the frequency is high enough. This is the fundamental circuit. He basically says in the article that this is the one that he found to be the most convenient. This was the one that he said created the most profound effects. So, this is the first patent that issued based on these new systems, and it's called System of Electric Lighting. And again, you see, that's the circuit method of conversion. And he's using the output to run light bulbs connected with only one wire to just one side of the secondary. Okay? So, I'm sorry, that's okay, we'll just go ahead and read this. To produce a current of very high frequency and very high potential, certain well-known devices are employed. For instance, as the primary source of current or electric energy, a continuous current generator may be used, the circuit of which may be interrupted with extreme rapidity by mechanical devices, or a magneto-electric machine especially constructed to yield alternating currents of very small period may be used. In another case, should the potential be too low, an induction coil may be employed to raise it. Or finally, in order to overcome the mechanical difficulties, which in some cases become practically insuperable before the best results are reached, the principle of the disruptive discharge may be utilized. So again, just what we said. So here it is. He's now taking the methodology and saying, I can produce a lighting system with this. And here's another quote from this patent. I would here state that by the terms currents of high frequency and high potential, unquote, and similar expressions which I have used in this description, I do not mean necessarily currents in the usual acceptance of the term. So we see right here in 1891, Tesla is feeling free to redefine all the terms. Here it is in his own words. So just so we don't lose our bearings here, let's review quickly the language which Tesla says he doesn't mean. Here from 1954, we have the wonderful Basic Electricity, and here's page 1. This is a great book developed by the Navy specialty schools to train new recruits in electricity and electronics in the early 50s. And I chose this as an example because back then, when you take somebody out of Appalachia who's a new recruit, you've got to start really at the beginning. So this is great because this is what we want to do. So they say, this is page 1, when electrons move, things happen. So, and here it is, gee. Wouldn't Tesla be happy? What electricity is, they're telling you, this is it. Okay, and what is it? Electron theory. Back then, they weren't as proud and haughty and just saying, this is the way it is. They admitted, this is a theory. So let's read it. All the effects of electricity can be explained and predicted by assuming the existence of a tiny particle called the electron. Using this electron theory, scientists have been able to make predictions and discoveries which seemed impossible only a few years ago. The electron theory not only is the basis of design for all electrical and electronic equipment, it explains chemical action and allows chemists to predict and make new chemicals such as the synthetic wonder drugs. A new day is dawning. Since assuming that the electron exists has led to so many important discoveries in electricity, electronics, chemistry, and atomic physics, we can safely assume that the electron really exists. Don't you love it when they're honest? All electrical and electronic equipment has been designed using the electron theory. This is a very important fact, folks. All electrical and electronic equipment has been designed using the electron theory. So if we're starting to deal with a form of electricity that has nothing to do with the electron theory, don't expect those meters to give you the right answer. They won't. Since the electron theory has always worked for everyone, it will work for you. Miracles. Okay? Here's a reproduction of page 48. Current flow in a wire. And here's what it says. Since electrons repel each other and attract by positive and are attracted by positive charges, they always tend to move from a point having an excess of electrons towards a point having a lack of electrons. Your study of the discharge of static charges showed that when a positive charge is connected to a negative charge, the excess electrons of the negative charge move toward the positive charge. If electrons are taken out of one end of a copper wire, a positive charge results, causing the free electrons in the wire to move toward that end. If electrons are furnished to the opposite end of the wire, causing it to be charged negatively, a continuous movement of electrons will take place from the negatively charged end of the wire toward the positively charged end. This movement of electrons is current flow and will continue as long as electrons are furnished to one end of the wire and removed at the other end. Oops, that's not supposed to be there. Okay. Got too far ahead here. Where did that come from? So, I'm sorry, we were reading this slide here. Oh man, this thing. Where's the AV guy here? We got to make sure. This thing is not happy. What is there? Where are we? No? Okay. I'm sorry, the thing's screwing up. So here's page 61. And they're going to talk about current is the rate of flow. Units of current flow, how current is measured. Current flow is measured by how many electrons are passing through a material in a given length of time. The coulomb is a measure of the number of electrons, so that by counting the coulombs which pass in a given amount of time, the current flow is measured. The unit of current flow is the ampere. 1 ampere of current is flowing when 1 coulomb of electrons pass through the material in 1 second. 2 amperes when 2 coulombs pass per second. Since amperes means coulombs per second, the ampere is a measure of rate at which electrons are moving through a material. The coulomb, which represents the number of electrons in a charge, is a measure of quantity. So that's a quick review of exactly what Tesla does not mean necessarily. Okay. So here's the patent that issued on the method and apparatus for electrical conversion. And again, you can see a much simplified version of what we saw in the article. Starts with a source, and he charges a condenser and discharges it and runs light bulbs and does other things. And he can charge one condenser and discharge it and run light bulbs, or charge another condenser and keep stepping this along. So here's what he says in the patent. I employ a generator preferably of very high tension and capable of yielding either direct or alternating currents. This generator I connect up with a condenser or a conductor of some capacity and discharge the accumulated electrical energy disruptively through the airspace and otherwise into a working circuit containing translating devices and, when required, condensers. These discharges may be of the same direction or alternating and intermittent, succeeding each other more or less rapidly or oscillating to and fro with extreme rapidity. So here he describes basically the system that I showed you in the article, method of conversion. And again, he calls for a circuit that includes a disruptive discharge. So, what's that? So here he says, but as a matter of fact, the air does never break down disruptively, if this term be rigorously interpreted. For before the sudden rush of the current occurs, there is always a weak current preceding it, which gives rise first gradually and then with comparative suddenness. So this is a standard type of air discharge where you get a very weak streamer preceding the big discharge, and that's exactly what a disruptive discharge is not. So anybody who's saying you can get radiant energy out of things like pre-glow discharge and things like this, here's Tesla in his own words, that's not what he's talking about. The ideal medium for a discharge gap should only crack. And the ideal electrode should be of some material which cannot be disintegrated. So here he's saying two things. One, that a disruptive discharge is just a single impulse that goes across the gap and then it's over. And that we got to find materials that don't disintegrate when we're doing this. This is going to be a recurring theme. The recognition that the movement, when you get the power up in these systems, matter seems to disintegrate. The medium which would merely crack when strained electrostatically, and this possibly might be the case with a perfect vacuum, that is, pure ether, would involve a very small loss in the gap, so small as to be entirely negligible, at least theoretically, because a crack may be produced by an infinitely small displacement. So, the term disruptive discharge can be defined as follows. An electric discharge from a low impedance source, such as a capacitor, characterized by a single crack. A unidirectional discharge with no alternations or oscillations associated with it. Now this is each individual event. It doesn't matter whether the next event comes in the opposite direction, but each one of these things has to be discrete in one direction only. We're talking about individual events. Ultimately, it boils down to a perfect DC square wave characterized by a high electrostatic tension. Back to the patent on electrical conversion. To express this result, I define the working current as one of an excessively small period, or of an excessively large number of impulses or alternations or oscillations per unit of time, by which I mean not 1,000 or even 20 or 30,000 per second, but many times that number, and one which is made intermittent, alternating, or oscillating of itself without employing of mechanical devices. So this is the kind of energy that will light light bulbs and other things with one wire, as we saw in the first patent. And this quote from back to the lecture says, "It has been a long time customary, owing to the limited experience with vibratory currents, to consider an electric current as something circulating in a closed conducting path. It was astonishing at first to realize that a current may flow through the conducting path even if the latter be interrupted. And it was still more surprising to learn that sometimes it may even be easier to make a current flow under such conditions than through a closed path. But the old idea is gradually disappearing, even among practical men, and will soon entirely be forgotten. 1893, closed loop, use of electricity in closed loops will, I mean, it's only being used by practical men, and they're almost gone. So, in 1893, when Tesla said this, he did not know that he would lose the Industrial Standards War. We were all taught that the battle of the currents was between Edison's DC and Tesla's AC, and Tesla won. We were taught nothing about the battle of the closed path and open path systems, and Tesla lost. But here in this article, sitting in the public domain for 113 years, is a drawing that shows 6 different types of motors that he can run on his one-wire impulse circuits. So here is the terminal of the, one terminal of the secondary of his power supply that Jeff Bahari had here yesterday. This is classic stuff. Basically, this diagram I didn't understand for years because he always shows the motors as this little block here. It doesn't look much like a motor to me, so when I would look at this, I would just kind of glaze over it like, gee, wonder what all that junk is. So, but when you actually read the article and go back and look at the thing, so I actually put a little piece of sticky tape over these two things to actually draw in, instead of replace this little box and actually show you what the motor configuration looked like. And this one right here is his standard capacitor run motor, where one coil gets the signal directly and the other coil gets the signal 90 degrees phase shifted by a capacitor. And he can, and so this thing gives you instant torque now. Every time an impulse goes through this thing, he gets one shot of torque. And so you've got speed control with impulse control, and away you go. No commutators, no nothing. This one has a very similar arrangement, except the capacitor is actually driving a second output system. He shows this is an interesting motor that causes kind of a magnetic drag lag effect. But when you read the article, he says this is the motor that has the big torque. So if anybody wants to look for a possible super efficient electric motor, I highly recommend you go back to this article and figure out what the heck this thing is. Because he says right in it, this is the motor. So what kind of electricity are we dealing with here? What kind of electricity runs motors and light bulbs with one wire and no return? Since in accordance with accepted views, in this experiment, the incandescence must be attributed to impacts of the particles, molecules or atoms in the heated space, these particles must therefore, in order to explain such action, be assumed to behave as independent carriers of electric charges immersed in an insulating medium. Seems incomprehensible. And again, it is of special interest for the thinker who inquires into the nature of these forces to note that whereas the actions between individual molecules or atoms occurs seemingly under any conditions, the attractions and repulsions of bodies of measurable dimensions imply a medium possessing insulating properties. So if air, either being rarefied or heated, is rendered more or less conducting, these actions between electrified bodies practically cease, while the actions between the individual atoms continue to manifest themselves. Tesla is saying that at the subatomic level, there is an underlying insulating medium present. because at the macro level, when the insulating quality of the air is rendered ineffective, the action of the electrostatic force is also rendered ineffective. Tesla's model of electricity includes electrons as well as another smaller neutral particle. The smaller particles transmit the electrostatic EMF, which propelled electricity forward, and the electrons actually provided the resistance, thereby slowing the flow down. Both particles, in order to be able to operate as independent charge carriers, must be moving within an insulating medium, such as a perfect vacuum or pure ether, as he states. Tesla's method of conversion, these processes all convert normal electricity into an electron-deficient form capable of transmitting longitudinal shock waves through the neutral particle flux. He did this by raising the voltage to very high values, which by itself reduced the electron current flows to very low values. He then compressed this charge by storing it in a capacitor. Then he would discharge it as a single coherent charge cluster, and then repeat the process. The successive discharges of electrostatic charge constituted the longitudinal wavefront. With the electrons out of the way, Tesla could propagate a purely electrostatic compression wave. He likened it to sound waves of electrified air. These electrostatic compression waves could be propagated from one location to another with no return loop in the circuit. The wave is characterized by a unidirectional flow of alternating zones of compressed electrostatic charge followed by a quiescent zone. These longitudinal electric waves can be represented as transverse oscillating waves, but that is not their true nature. Lacking electron movement, their power quotient is routinely underestimated by conventional measuring equipment and techniques. For Tesla, the term current can be defined as any of the following: electrons and neutral particles flowing together in a wire. Electrons and neutral particles flowing together in a wire. This is standard DC. Electrons and neutral particles oscillating together in a circuit. This is standard AC. Electrostatic pressure waves propagating through the neutral particle flux with little or no electron movement. This is what he gets out of the system he calls the method of conversion. He's converting this stuff into this stuff. Longitudinal electric waves, no magnetism. What better proof of this than patent 514168, titled Means for Generating Electric Currents? Here now we see very clearly that he's talking about this system, and he's just saying this is an electric current. Okay, and what is he doing? He's basically got the same circuit, except now he's got the capacitors in oil. He's got the high voltage transformers in oil. He's got the circuit controller in oil. And he's pumping this oil around and cooling the oil, all to create his high voltage lighting system again. So, let's read. In systems of this character, when the high frequency of the currents employed is due to the action of a disruptive or intermittent discharge across an air gap or a break at some point in the circuit, I have found it to be of advantage not only to break up or destroy the least tendency to continuity of the arc or discharge, but also to control the period of the reestablishment of the same. And from investigations made by me with this object in view, I have found that greatly improved results are secured by causing the discharge to take place in and through an insulating liquid, such as oil, and instead of allowing the terminal points of the of the break to remain at a uniform distance from each other, to vary such distance by bringing them periodically in actual contact or sufficiently near to establish the discharge, and then separating them, or what is the equivalent of this, throwing in and out of the gap or breaking a contact bridge at predetermined intervals. So here, in 1894, Tesla says he's using this to control the period. Not only control the frequency, but to control the period. So he's invented pulse width modulation, DC pulse width modulation, 1894. So again, for Tesla, the term frequency can be defined as any of the following: the number of sinusoidal alternations per unit of time in an AC signal measured in cycles per second. The rate of which DC impulses are produced in the circuit measured in pulse repetition rate. The recognition of how often any electrical event occurs per unit of time, or simply the duration of a single DC pulse. Any of these things he uses periodically, he uses the term frequency to describe. And again, apparatus for producing electric currents of high frequency and potential, September 1896. Same circuit again. So here's what he says. The object of my present improvements is to provide a simple, compact, and effective apparatus for producing these effects, but adapted more particularly for direct application to and use with existing circuits carrying direct currents, such as the ordinary municipal incandescent lighting circuits. So here he's saying, I've invented a new simple circuit that you can just plug into the DC power supplies that are available in many cities, and then you can run systems with my system from the electricity that you're being given by the utility. Okay? And again, this method of regulating apparatus for producing currents of high frequency. This is the patent pretty much that Jeff Bahari was showing the other day. This is very straightforward, and I want to read a number of quotes from this. The energy of the direct current supply is periodically directed into and stored in a circuit of relatively high induction, and in such form is employed to charge a condenser or circuit of capacity, which in turn is caused to discharge through a circuit of low self-induction containing means whereby the intermittent current of discharge is raised to the potential necessary for producing any desired effect. This is the quintessential description of the solid-state power supply that produces these effects. So what does he do? He takes DC and charges an inductor. Okay? With a periodic break. So he's pulsing energy into the inductor, and when he breaks, it discharges. That discharge he puts in and uses to charge a capacitor. When the capacitor is full, he disruptively discharges that across a gap to produce his effects. But Tesla has new discoveries to report in this patent as well. It is well known that every electric circuit, provided its ohmic resistance does not exceed certain definite levels, has a period of vibration of its own analogous to the period of vibration of a weighted spring. In order to alternately charge a given circuit of this character by periodic impulses impressed upon it, and to discharge it most effectively, the frequency of the impressed impulses should bear a definite relation to the frequency of the vibrations possessed by the circuit itself. Moreover, for like reasons, the period or vibration of the discharge circuit should bear a similar relation to the impressed to the impressed impulses or the period of the charging circuit. When the conditions are such that the general law of harmonic vibrations is followed, the circuits are said to be in resonance or in electromagnetic synchronism, and this condition I have found in my system to be highly advantageous. So he's discovered resonant harmonic oscillations powered by DC periodic impulses. And he's saying basically he can create them by observing certain circuit design criteria rigorously. By 1897, he's got this patent, electrical transformer. And again, this patent shows one-wire power transmission. Okay? So basically, he's got the source of the disruptive impulses running the two-turn primary, and the secondary basically is grounded and goes through one wire to an analogous circuit, which then comes down and is also grounded, and then from the secondary output here, he can run all his light bulbs and all his motors and all this other stuff. And the energy is transmitted from place to place on one wire. And here it says, the improvement involves a novel form of transformer or induction coil and a system of the transmission of electric energy by means of the same, in which energy of the source is raised to a much higher potential for transmission over the line than has ever been practically employed heretofore. And the apparatus is constructed with reference to the production of such a potential, and so as to be not only free from the danger of injury from the destruction of insulation, but safe to handle. So all these years, he's been working on how to get this energy to move in his systems without destroying the insulation on his coils. And now he's saying here, he's announcing he's starting to make progress in overcoming the destruction from the bombardment of this material so that it doesn't destroy the insulation. And this is the bombardment, the high-speed, electrostatically driven bombardment of these microscopic particles that causes the destruction of the insulations. But he's overcoming it. And again, in constructing my improved transformers, I employ a length of secondary which is approximately 1/4 of the wavelength of the electrical disturbance of the circuit, including the secondary coil, based on the velocity of propagation of electrical disturbances through such circuit, or in general, of such length that the potential at the terminal of the secondary, which is more remote to the primary, shall be at its maximum. So here he's saying the output section is now built to the physical dimensions equal to 1/4 of the wavelength of the signal moving through it. Meantime, the gas car is starting to appear, and he says, well, gee, I'll just use my circuit again and throw the spark gap in the cylinder, and gee, we can make these cars go. So here's his capacitor discharge spark igniter. But it's the same circuit. This is all he's doing. Finally, again, this group of patents, they didn't issue on the same day. They issued a couple months apart. But we've got system for transmission of electrical energy and apparatus for transmission of electrical energy. Notice the drawings are pretty much the same. These patents show further improvements to the system, showing the wireless transmission of power by using the ground as the one-wire contact. So here, instead of having the output from this one go over to here on a wire like we had in the transformer one, now we just go up to an elevated capacitance, and now he's using the ground actually as the conductor, and using this elevated capacitance as a virtual ground in the system. So this is the basis of the wireless broadcast of power, using the ground as the one-wire in the system. So the question is, does any of this stuff work?
There was a ground connection in the one wire.
Yes, but you could consider the ground and the other one as a closed loop for current flow. There, that was clearly open loop. This is an image from a film that we did in Borderland Labs in 1988. Here's Eric Dollard sitting in front of a system. This is 2 flat pancake coils built exactly like the patents that I just showed, and showing a connection between them using just the one wire connection between them. And the question is, can these systems demonstrate one-wire power transmission, radiant energy emissions, and other phenomena? The answer is yes. And if you haven't seen this video, by the way, it's still available, and I highly recommend that you take a look at it because we demonstrate this stuff in real time. Okay? These are just clips from it. So here's Eric. This light bulb here is glowing, and right now it's connected completely in a closed loop across the secondary of this flat pancake coil. This is one of these Fisher Medical Tesla coils that Jeff Bahari was talking about. This is a big capacitor, and this is 2 hydrogen thyrotron spark gaps to create the disruptive discharges to run this. And so what Eric does is he reaches over and grabs the wire and lifts the wire out, and the light bulb stays lit. Now it's running as a one-wire power transmission. No closed loop. Plenty of current running the light bulb. There's the end of the circuit. Here we show, in this thing right here, there's a strip of copper hanging right next to it. This is a light bulb with a vacuum in it, a standard filament and a vacuum in it. And this is set up to run on this system. The copper strip is hanging right next to the bulb here. As soon as we turn the light on, stop. No. These buttons are sticking. Okay. As soon as we turn the light on, the radiant emissions from the light bulb charge the copper strip, and it is immediately attracted to the light bulb. We do it about 5 or 6 times on the video. The charging effect is rapid. And to move that by electrostatics, it must be charging to thousands of volts very rapidly due to the radiant discharge from the vacuum bulb. This video is still available. If you haven't seen it, I encourage you to take a look at it. And finally, this image of Eric Dollard and an associate lighting a light bulb in their hands, standing in front of the radiant field of this big push-pull system. This guy's holding his hand here. He's holding one element of the light bulb here. This is a filament bulb. This is not a fluorescent bulb. They're lighting the filament. Eric's holding the other side with his hand over near the other side. You don't feel anything when you do this. I've lit bigger bulbs than this in my hands next to something like this. You feel nothing. You don't feel any kind of shock. When you make and break the contact, it's completely clean. The light bulb just goes on and goes off. There's no arcing. There's nothing.
Do you remember everything?
This is not electromagnetic waves. This is not some goofy, this is a completely different form of electricity. This is the kind of electricity that Tesla wanted to run the industrial age on. This is nothing, okay? This is a very, very small demonstration of these facts. But this is why Tesla says that Maxwell is a poet, because this kind of electricity is not described in his mathematics. Okay, here's means for increasing the intensity of electrical oscillations, 1901. And here Tesla's showing, all you have to do is place the secondary down in liquid nitrogen, lower the resistance of the oscillating circuit to near zero. So, in 1901, Tesla is telling us he's discovered superconductivity, low temperature superconductivity, 1901. When a superconducting coil is tuned to resonate with the electrical dimensions of the Earth, the harmonic oscillations grow spontaneously. That is, the natural medium can add energy to the system faster than the resistance and other impedances damp it out. Hence, the oscillation grows. This is how it's done. Okay, well, we've finally gotten back up to where the radiant energy patents issue. I'm going to just glaze over them once quick. And again, here means art of transmitting electrical energy through the natural mediums. Further improvements after building and testing the Earth-tuned harmonic oscillators in Colorado Springs. Now here in 1905, he finally gets the patents issued on this, and Tesla reports the discovery of stationary waves, standing waves, and other continuously available signals from the natural mediums, powered by lightning strikes and other phenomena. And he shows also another PWM controller here for controlling the period of the input oscillations. And finally, in 1914, the patent finally issues on his abandoned Wardenclyffe Tower complex. By this time, he has lost the economic war about which kind of electric current will be used on an industrial scale and made available to the public. Transverse electromagnetic waves have been adopted as the industrial standard, and Tesla's longitudinal electrostatic compression waves have been frozen out of the market. So, let's go back now and take a look at what this is. What I haven't told you about was that as he improved each set of these patents, he would go back and then not only get patents on the method and the apparatus that did this, but then he'd go back and get separate patents on all the different components. So the ones where we saw that he was running the whole system in circulating oil, he got patents for oil-filled capacitors. He got patents for manufacturing oil-filled capacitors. He got patents on a wide variety of circuit controllers and on and on and on. So he would map out the territory with the big patents and then go back in and mop up the details with further patenting. So basically, what the radiant energy patents are is in that zone. He's going back and mopping up all the other little patents that he's discovered. Okay, and here we can see this is the receiving section of the wireless power transmission, and here is the receiving section of the radiant energy patent. And what you see is that this here has a big ball of metal up here going down through an inductor and then down to the ground. And this has a big chunk of metal up in the air going through a capacitor down to the ground. And so what you can see is he's saying, I can handle impressions from the natural mediums in a dynamic flow or in a static flow. I can oscillate these things if they oscillate, or I can collect them if they are static. And so you see that these two patents are inverse analogs of each other, and they're both about collecting electrostatic impulses from the environment. These are oscillatory type, these are DC type. So this is possibly sunlight, bombardment of particles by sunlight. This is getting pressure waves from lightning strikes thousands of miles away. Okay? So this is the electrodynamic, this is the electrostatic. So now you see where the radiant energy patents fit into the whole thing. So here's one possible application of a radiant energy system simply as a solar collector. You can look at this as picking up a natural source of radiant matter, such as sunlight. You can charge a capacitor. You can discharge it through an inductor. You can step the voltage down. You can rectify that, charge another capacitor, and then periodically dump that to a battery. It's a very straightforward process. Most of the patents that cover things like this you'll find very well represented in the patents that have recently issued to John Bedini. Okay? But this isn't the only thing that you can do. You can collect radiant matter on plate P from artificial sources. And here's, of course, how Ed Gray ran his machine. It's just like the thing shows, it's just a stepper motor. And here you can see, with this new photograph of the conversion tubes, plate P isn't very big. So plate P doesn't have to be very large, and the power produced by these does not have to be feeble. There are dozens of natural signals in the environment. All you have to do is create a receiver. Create a tuned receiver if you know what signal you're going for. If you're going for, get out your test equipment. Find out what signals are just sitting there from the lightning. There's lots of them. Tune your thing to quarter wavelength. And again, this doesn't rely on the sun then. Tune this to the quarter wavelength of whatever signal is out there. And then you can just step the voltage down, rectify it, charge a cap, and dump it to your batteries or any other appliance that you want, and pick up radiant energy from the environment on the AC side. Okay, so radiant energy can be defined pretty much as follows. Energy or useful work which may be derived from apparatus designed to intercept the streams of radiant matter. This is this super small particle that Tesla discovered. Such streams of radiant matter may be gathered either from natural sources, such as sunlight or lightning-induced planetary standing waves, or from artificial sources, such as the emissions from circuits powered by disruptive discharges. When intercepted, these streams of radiant matter impart an electrostatic charge to the circuit that can be accumulated in a capacitor or oscillated in a tuned series resonant circuit. When sufficient electric energy is stored in the system, it may be discharged through an appropriate circuit to perform useful work. So by June of 1900, 7 years after he said, if we ever figure out what electricity is, it'll be the greatest day, here's what Tesla said. Whatever electricity may be, it is a fact that it behaves like an incompressible fluid, and the Earth may be looked upon as an immense reservoir of electricity. Obviously, this does not compute if you're talking only electron theory. He is not talking electron theory. He is talking about something that acts as an incompressible fluid. In 1902, Mendeleev stated that his periodic law predicted two inert chemical elements lighter than hydrogen. The lighter of these two elements would be an all-penetrating and all-pervasive gas. Tesla believed he had discovered this gas and that it was responsible for the electrostatic field. Even today, as you can see on the periodic table, each group of elements has two full rows before the pattern changes. The elements before hydrogen and helium are missing. It doesn't matter if we call Tesla's neutral particle Mendeleev's lighter than hydrogen gas, or even a new flavor of neutrino. The neutral mass charge carrier is there, and its action is responsible for most of what electricity does. We live in a sea of energy. The sea of energy is the electrostatic field of the planet made up of Tesla's neutral particle flux. The Earth is full of it, the air is full of it, the sunlight is full of it. we're acting like birds, sitting on a high voltage line, wondering where all the energy is. As long as we build circuits that are referenced to ground in a closed loop, the natural medium is prevented from producing the potential gradient in our circuit that we can draw energy from. Tesla always referenced his energy systems to at least 2 points and left the section that accumulated the energy in an open circuit so the natural medium could provide the potential difference between those points. Energy could then be extracted from the circuit between those 2 points of reference at the rate of the natural energy accumulation based on the size of the device. And here's what Tesla said on March of 1904 at the end of his article called The Transmission of Electric Energy Without Wires. When the great truth, accidentally revealed and experimentally confirmed, is fully recognized, that this planet with all its appalling immensity is to electric currents virtually no more than a small metal ball. And by this fact, many possibilities, each baffling imagination and of incalculable consequence, are rendered absolutely sure of accomplishment. When the first plan is inaugurated, and it is shown that a telegraphic message almost as secret and non-interferable as a thought can be transmitted to any terrestrial distance, the sound of the human voice, with all of its intonations and inflections, faithfully and instantly reproduced at any other point of the globe, the energy of a waterfall made available for supplying light, heat, or motive power anywhere on sea or land or high in the air, humanity will be like an ant heap stirred up with a stick. See the excitement coming. Thank you very much.
Sorry about that. That was me. Thank you, Peter Lindemann. Now, if we want to, we can take one or two quick questions. We're running just a teeny bit behind for break, and then we'll come back for the extra session. But if anybody has a quick question or two, come on down front to the stage left here, your right, and we'll take 3 questions for the first 3 contestants that make it down front in a hurry. Okay, do we have any questions for Peter Lindemann? Okay.
Thank you.
Thank you very much, Peter Lindemann. It's been an honor and a pleasure having you, sir.